name is Azhar Kimanje, and I'm here to talk to you guys about one of my favorite things, Gaussian splatting. And in this case, we're going to be using it for storytelling. I ran into Gaussian splatting when I was doing a lot of photogrammetry work, doing a lot of 3D reconstruction for architecture, and I realized that there are better ways to represent 3D scenes. It just wasn't feeling immersive enough. And behind the scenes, there's this thing called NERF, where there's neuroradiance fields. So it was a technique. Think about it as a way to represent a 3D scene. And now when I run into Gaussian splatting, I thought, wow, this is pretty cool. I think this is something we could use even for storytelling because of how immersive it was, of course, but also how true to size everything felt like when I used Gaussian splatting as my technique. And we're going to talk about a little bit about that today. This is an image I got from a Medium article that I cited. I think it's an amazing way to also get introduced to what the technique does and how many other ways you could apply it for yourself. So what's on our agenda? I'm going to explain what technology is. I'm not going to go into depth or the research. And then I'm also going to discuss the ways we can apply this method. We're going to showcase how this is even possible for 3D reconstruction, and why do I think it's accessible for storytelling. I think storytelling is a powerful way to remove any entry barrier for technology, but also a way to learn new technology as well. And another thing is use cases, other cool ways I've seen this get applied. We'll get right into it. What is Gaussian splatting? Well, this is another way, as I mentioned, to represent 3D scenes, if we were to keep it brief. And the only reason it stood out for me, and is why I want to use this as a definition, is because things do look more true to size and more photorealistic, allowing you to even get that extra step of immersion. If you guys have ever been in a VR headset, you always have this feeling of, okay, this doesn't feel real enough. This doesn't feel true to size. The car looks much smaller than it actually is in real life, and you can't kind of pinpoint why. And yet now there's this technique called Gaussian splatting, which uses Gaussian splats. And these are also trained just like any neuroradiance field, where we use, there's an algorithm behind the scenes that kind of 3D reconstructs the frames from the video, but this time represents them as these blobs, right? So since it's a Gaussian splat, it's using blobs, as I mentioned in the first scene here, where you kind of see these colored blobs that allow you to, all the different combinations of these colored blobs make up a particular point in a Gaussian splat 3D scene. And all the different combinations of the different colors allow you to see different colors, right? And this is very powerful because in our case, we were using just regular drone video, regular 360 video, and it of course captures about almost like 60,000 frames. We get to pick whatever we want from those frames and train those blobs and that later become those particular color points, right? If you guys have heard of things like point clouds, we're going to get into how that also plays a role in this. And my workflow is, for me, it's very interesting. I try to minimize just thinking whatever's going on behind the scenes, which is just 360 video, a video editor to edit the 360 video, a deep learning training model. Think about this as something that will get abstracted for any beginner, which is you're going to be using an app called PostShot. It's very famous at this point. Everybody's been using it. And then you can deploy your application anywhere. And we're going to talk about the apps where you could deploy this application as well. So here we have a Gaussian splat of a park, and this is a project I was doing with the Judkins Park reconstruction. It was pretty interesting because what happened here is there was a lot of kids and families and community members who spend a lot of time at the park, but they had all these things to say about the park, where it should go for this reconstruction. What should it look like? How do we make it more accessible? And they had a lot of great ideas, but what I noticed helped a lot was having a point of reference, and not just a cartoonified, drone picture so that they could point out. They wanted to walk in the park. They wanted to be at the park and say, this is where I want more wheelchair access. This is where I want the bathroom to get moved. And the people in the community had so many other things to say about what was working and shouldn't change. And there's nothing better than being in the place and making it clear to the architect compared to saying, well, it's somewhere around here, because most of them could not get to the park to explain the ideas, mostly for this particular conversation. And having a Gaussian splat, something true to size, to bring the ideas forward was very important. And I think it told a lot of stories about how technology as a tool can really bridge the access gap. And here's just an example of a 360 video of the place, right? Taken by an amateur flyer, just amateur flying, I'm referring to me. I was able to just fly a drone around this, take a 360 video, and train a Gaussian Splat 3D scene to look like this, right? So this 360 video is what actually was used to reconstruct an entire 3D scene using Gaussian splatting. So there's frames, and for those who do not know, I'm just gonna breeze through this one. Every video is made up of frames, and for whatever length of video, there's whatever amount of frames, and all of them are captured at a quality of the camera. Some are in 4K, some are in 1080p, some are in 720. This was simple. This was 1080p. As you can see, it's very great, and a rainy day in Seattle, it's always going to be great. But we were still able to get a very immersive version of our park, and it was able to deliver the use case, which is people going into VR and explaining to the architects without having a technical background what they actually wanted their park to be like, right? And I think that tells the most important story. Another thing I wanted to talk about is the accessibility of drones that could be used to do more of these environmental use cases, which is, as long as you can take a video, it will have frames. So as long as it contains frames, you're good. The other piece I wanted to talk about is LiDAR data. Most of the times, drones do get more expensive with the more lighter cameras, but I wanted you guys to know that even the DIY drones from Amazon do have a bit of LiDAR in there, and these are just small bits and pieces that are important for the deep learning model to use as a point of reference, to use to recreate 3D out of these videos. Another important thing to consider is the drone size. So if you are buying a drone and you want to recreate 3D using a drone, make sure the drone you buy is below 250 grams. This is important because drones are unmanned aircrafts, which means that if it's too big, you will get in trouble. And if you do not have a license, which I would advise anyone to get a license if this is something you're interested in and you see yourself flying much bigger drones, as you see here on the right. But drones actually have so many other use cases. The one on the bottom right is used for irrigation. The other one on the top is used for transportation and delivery of much bigger things. So yeah, there's so many ways you could use these drones, but for our use case, and the things to consider is keep it below 250 grams, get something at Best Buy, get something on Amazon. You will be able to get started to recreate your own stories. Another thing you could use, and this is not a thing to consider, this is a tool, right? This is CapCut. You could use even your phone. You don't need a specialized video editor. I would imagine CapCut only comes in if you want to combine multiple videos of the same scene with particular super angles to make it better. But you could get even video from YouTube and train a Gaussian Splat. And this is important because you do not have to have a drone to get started, right? If you have a 360 video of a particular city, you can train a 3D Gaussian Splat on. And this is important to show how accessible this is. And these apps are also free. So how does it work? I thought this is important to talk about because for me, I think most people think it's so far to get into this technology. You kind of see it on TV or in an ad and you're like, yeah, this is too far. But as long as you have a drone and you have this app in the middle, we're going to call it Post Shot because this for me has been one of the most successful apps in making this technology accessible. You already have a deep learning training platform. You don't have to get a degree in machine learning to get you started, as long as you can get the data. And now we know we don't need a drone for the data. But if you do have a drone, you can pick the places you want to get your video data from. You give it to this Post Shot app. It does the deep learning behind the scenes. As you can see, this is a flight path that I took with my drone. It's not very 360, but I wanted to talk about why it's important that it's 360. Well, 360 allows you to have a point of reference. And if you do not have a point of reference, it's particularly hard to reconstruct really good 3D scenes if the video data does not have a 360 view of the objects or the pieces within the video. And it will be forced to assume or kind of not accurately represent what is missing. So having really good 360 video is always a good start. And how does that look like? So first of all, it will render a point cloud on my left side, as you could see. And this point cloud is going to be a way for you to kind of see this whole scene come to life, right? As the machine learning, or I would say the deep learning, is happening behind the scenes, it's going to take a point cloud. And this is much more accurate with the more lighter you're able to have within your frames. And whatever more lighter data your cameras have, this of course just keeps getting better. And that's how it's able to represent every point where the light was bouncing off and back to the camera. And for my drone, these were the points, and on the right you can see the flight patterns, and PostShot is the app you're looking at on the right. This is how easy it is to use. You literally have buttons to turn on the point cloud to see your flight path. Well, mine wasn't so good, but just imagine it was also 360, because this is how the video or the 3D scene came out. And this is a real scene. I could put this in a game engine. I could put this on the apps we're going to talk about, Gaussian, Polycam, and you will be able to experience this particular scene in VR as well. So what is left? Well, these are ways you can deploy these quickly. I'm going to call it an hour, 30-minute workflow, depending on how much you're training. If you wanted to get something quick, of course, it might be a shorter or longer time, depending on what it is as well. But right after you're done training and you have a file type, and the file type is .ply or .splz, well, those are the file types you would use to upload to Polycam or Gaussian AI or WebXR and have your 3D Gaussian Splat environment ready for any user to experience and tell stories about. So just some of them. There's so many others, but these are some of them that I kind of highlighted in the most case or most easily used. The use cases are many. I mean, I took a chance on using this for storytelling, but I've seen this getting used for game reconstruction. And the most exciting piece about this and having true to scale 3D is 4D Gaussian splatting videos. This is exciting for me because imagine you are in the movie and you have your favorite actor, and instead of just watching the movie in a 3D environment on a 3D screen, you're actually standing next to your actor in the scene, right? You're seeing the events transpire in real time, but not just because they look good and they're clear or 4K video and standing next to you. These are true to size, and that's the ability we get from 3D Gaussian splatting, and it actually opens the door for 4D Gaussian splatting, which is 3D, think about it as static. Well, 4D Gaussian splatting is dynamic, right? Those blobs that we talked about at the beginning are actually moving, and they're actually making whatever animations the engineer behind the scenes wants them to make. And this will be another opportunity for movies to take it to the next level, which is the 4D version of Gaussian splatting. Well, that is all I have for you guys today. I think this was a fun project, and I definitely have all the resources for you guys to check out after you kind of learn from this, or even have any questions. Feel free to use my email to reach out to me. I think I learned a lot being able to try and explain this in layman terms, but also being able to show the quick ability to get started, right? You do not need to be an expert. You do not even need a drone. But the way I did it is I used a drone. And again, you do not also have to know everything behind the scenes. There are applications like PostShot. Even you can also train on Polycam, actually. There are ways for you to kind of abstract the whole machine learning missing piece for you to get started and still get what you want and still get the renderings that you desire, and also why not get more curious before I could tell you and ruin everything for you as well? So once again, my name is Azhar Kimanje. Feel free to use that email to reach out to me, and my LinkedIn as well. I'm always active, and I'm gonna let you have a beautiful day.